like video understanding. You can of course understand. Um,
Yeah, go for it. Absolutely.
so how do I
Then you should be able to select. Gotcha.
things that have been free feel to I don't have maybe you can agenda that I have modeling in general and extend that to like active learning is that any kind of deep learning model should learn.
Anytime active learning isn't.
I should share the links that you can teach the understand what you're typing and your thought is an extension to that with like image sorting and recent package made by it sorts all your images query any search and yeah this base which uses like embeddings from those but the point here around embedding of each image to not productize it and you can run it on your phones something like that.
Yeah, definitely.
So yeah, and the motivation to this is that I really need an album sorting for myself. I have so many food shots and images, and I had to download all the image and do stuff with it. So which is hectic. So how we can do that on the cloud with just links of images? I actually joined this lab like around 1 month ago, 1.5 months ago. I just needed chat. So yeah, just wanted.
Absolutely. With for like good stuff like this, like that's super dope.
So let's actually jump down. We have
Hmm.
like half an hour, I think. So for reinforcement learning, it's been a huge topic with OpenAI and ChatGPT because they have basically introduced this and in the realm of LLMs, and it has increased the total performance. So below you can see how RLHF works by hat, which is basically a target. So what this does, it creates like a contrast on what is good, what is not, and basically we create like a maximum likelihood of this difference, and we create a reward system for it. And the LLM policy here is basically the large model, the language model, sorry, and that will basically uh, find out a score of this preference, and it will use that as feedback, and it will update its gradients, how the human or the user thinks, how the responses for it should be. So it's basically a personalization, and obviously will you know re- but DPO is very quick and easy. What DPO does is it basically just creates a maximum likelihood, the same as this, and it just updates a gradient using that likelihood without any prior this code in this. And this is tuning. I mean by changing how the model responds according to a certain data set or a certain prior data that you already have, right? So here, meaning that so you can get this using synthetic data, or in the other way, vice versa also. So if you have a data set with some target responses, you can basically synthetic contrast would actually strengthen the language model's understanding on how the response should be, and the gradients will be basically updated to that. And at the output, you will basically get a very good performance on like this kind of data that you have, right?
So like we have the in both data sets look like.
Yeah, being budge me here. So yeah, I'll actually okay. Actually, here. So the idea here is basically we made in a language model using now using SFT updating the gradients. That's it. Just and if the response is not same as gradients, right? And that is fine to do RLHF. That improves the performance. Now you can replace this RLHF with DPO, right? And that means that you don't need any UW, and then synthetically you can use other. So I did some experiments. Contrast looks like. So yeah, the model selection is important. So first I surveyed a few small gaming data set with some target prompts, and basically after SFT, orange color one is the SFT, and SFT plus DPO is basically this maroon color one, right? And this becomes rapidly goes down if the data set size increases for DPO. Yeah, and this is what I observed. So SFT DPO is very necessary for if you're fine tuning, because there are yeah
Well, yeah. It's I
yeah
recall. Yeah.
yeah. So the maroon one is SFT DPO, and sequential manner. Well, it did not perform very great, but it helps in like generalizing. The DPO was way less down here. So, but the problem with DPO, what I saw is that it uh, started overfitting, meaning that it started giving responses like very close to the one on the dataset, but you're not expecting. For example, I asked it like what kind of games are prominent that it has seen in the dataset in after basically fine tuning on DPO, which is a wrong response. You want to know exactly like from on um, overfit on the dataset, so that's not good. So I tried SFT plus DPO. It had well. It would give me the correct answers for example, the same prompt that what kind of games are prominent, right? But very close basically. But DPO's responses were still again overfitting, while SFT and DPO wasn't. So SFT is important, um, and yeah, only SFT doesn't work. It takes a way longer time to converge. But yeah, SFT DPO was, I think I would prefer that for any.
I believe they have like a DPO only, and then they have an SFT and DPO, but I don't think they have SFT only. Or was one of them? One of the three potential.
I would always prefer if you're taking any data set, just use SFT plus DPO one,
Yeah.
because that's the best quality you will get, yeah, for fun. And yeah, I was gonna talk about this, but real quick, I think I compared 5.2 and Llama. I decided to Llama 2 for like some fine tuning tasks and to check out how it performs. So yeah, I'll quickly go through like how I designed the synthetic models. So basically, I used Together API. So Together, right? So they have a really great pricing model, meaning that all the 7B to less than 7B models was way cheaper than the others. And also, when you sign up right now, you will get around $25 credit. So basically, you can run around like 1 million prompts, 1 million tokens, and yeah, you can basically really quick because yeah, Quinn is very popular for Chinese datasets. Vicuna, I'm not just sure, but I heard I read on Twitter that it's good. 5.2 from Microsoft was a very small, and so if you compare that with the recent ones like the Gemma models, Gemma models are way better than 5.2. So 5.2 is like very compressed version, and worst was 5.2 response. So
Oh,
and it basically repeats
FYI.
the outcome.
I will
Yeah.
mention that one of our sponsors for this event, Fireworks.ai, also has the similar 20. Yeah, so
Okay.
they're pretty competitive with. So they're 20 cents up to 16B, whereas I think Together kind of chunks it, divides it a little bit more. You might want to know about it too, Manoj. There's a form you can fill out in announcements right now, and that'll get you $15 of credit with Fireworks. FYI, if you end
Oh,
up needing more of
oh,
that.
okay.
Yeah.
Look
Just
into
as a
that. Yeah,
little
for sure.
side note. Yeah, absolutely.
That's cool. So, what was the name? Actually?
13B that they said. Oh yeah, so they can go up to 16B at 20 cents, whereas as soon as you hit the 13Bs on as well. Yeah, it's another like two cents USD, but every cent counts, I guess.
Yeah, for sure. I'll try that out. Yeah. So for synthetic models, I think the code was pretty easy. So you basically, which is the input prompt, it's chosen, you reject it, And this is the copy actually. So, and the score chosen and score rejected. So chosen is the one that you want to fine tune on, basically the target
Hmm.
data, all the samples. So what this code does, it randomly selects any one model and then gets and basically samples the output from that. Like for example, it will go through, if there are four, it will select any one, it will select the Kona and get its response and add it to this um, data set. And the score rejected and score rate, like score chosen will be any random score between 0 to 5, and score rejected, sorry, it's the other way around. So score chosen can be any random number selected from 5 to 10, and score rejected will be any from 0 to 5, the responses. If the score pushed to respond like the rejected one. So we have to basically keep it on a separate distribution. But if you can also basically, yeah. So yeah, I think yeah, that's how we basically create the synthetic data. 1,000 samples, but it's very clean. There's no mistakes in the dataset, so it was my first reference. And I created a system prompt to. So let's move on to, yeah. This was my get the best fine tune models from the like the simplest one that works right now. I think SFT DPO is something that I would prefer always. Okay, cool. Let's move on to like image sorting. This is interesting because here, so of images, and you can those images. This guy CTO Junior did. He basically used this package and tried to sort out like all the images which has Pepe in it from his folder. And yeah, it takes a while, but it does actually pretty brilliantly.
Context to find the same
Yeah,
blob of
yeah,
pixels.
exactly. But the images are pretty small. Like it can range from around like maximum 500 to 500 pixels. Yeah, but it works. So you can see like it's not very slow, fast, but it's using a GPU like 4090 at the back end. So yeah, make it faster, have better throughput, less latency, and so on. But yeah, just to explore how memory option. So in this package, we can basically use like a Streamlit interface. You can connect your data set or set of images, or you can use CLI like CTO did, CTO Junior did. And the basic interface, basically, it will start a query flow with text to vector. And if it's both, it will combine both text and image vector. So this is pretty interesting. Okay.
Yeah.
Interesting flow. So, and uses that and builds a tree map and database. It ranks all the images that are picked up by that index through similarity, and the similarity is simple KNN. Basically, it will check the closest index to that particular index,
Mm.
the top 5 or top 10, and so on. And it will use that and then convert to file paths and return the file paths. Create the embedding if it's an image, and create a vector if it's a text.
Mm-hmm.
Yeah. So yeah, this is the flow. But the interesting thing is that they haven't implemented any kind of way to, the way to go about that is to reduce this latency by using Onyx. So, and then Onyx already have like a web, what do you call it? CPP web or something? No,
Yeah, WebGB.
have their own Onyx runtime for browsers. And then, yeah, basically you can use that and run the Onyx model and create the embeddings quickly on the device. And you can host it on your laptop or your mobile. And we'll see the progress in next month around the end of
Awesome.
it. Thanks for tuning in. Bye.
Is mixed role, and the reason they offered the either the single one and then the SFT and DPO was I think maybe because and DPO model was tone for lack of a better term, where it's like you can tell it's like just sort of like defaulting to something that's more boring, essentially. But the it's
Oh,
interesting
what
that
was it like?
hmm?
SFT DPO one was boring.
Both, because like SFD, like it would get too it was like the responses didn't have enough salt in them, I believe, was kind of
Mhm.
general complaint, where people were saying it was boring to get responses from it when they were just kind of chatting and playing with it or whatever. Um, but I'm very interested in the results of your current experiment. Actually, I uh,
Sure.
I too also need a an image sorting utility, or rather, I mostly need a good VQA model, which like now you can
Exactly.
just do
Yeah.
it with Vision, but yeah, having like a
Yeah.
localish one
Vision is
that's
too much.
optimized would be freaking sweet.
Yeah. It's small.
Less like your phone can just see now, um, if you were to get it to a certain point of efficiency.
Yeah. Like none of them because it's obviously like a large model. But yeah, Moonring is like the small version of like ChatGPT 4V, and it's basically made from like Lava 1.8.
Sure, yeah,
Yeah.
I freaking feel free to ping me or whatever, and then I'm usually in the lab